use a sign chart to determine the intervals on which each function is increasing or decreasing.
Yes.
Oh, I didn't do it. What's it, 289?
Then verify your algebraic answers with graphs from a calculator graphing utility. In other words,
It's like 289.
graph it yourself. So this is first derivative test, right? So we just need to take first derivative. That's not that hard. It's just the quotient rule. Where is this function undefined?
At x equals 2 and negative 2. The denominator is 0.
Where the denominator,
Oh,
he didn't look at it very carefully. So the denominator is never 0, right? So this function is defined everywhere. So now let's see, can we do this without pulling it into pieces? Or what, for the quotient rule? Do you want me to pull it into pieces off to the side or not? Does it matter?
No.
No, yeah. Yeah. We'll do it fast. There we go. So it's going to be G times F prime minus F times G prime over G squared. So my derivative is x squared plus 4 minus 2x squared over that thing. And negative x squared plus 4. All right, so we're looking for where the first derivative is 0 to find the critical numbers. So we say, where is this 0? Well, we can't manipulate that thing at all to make it 0. So really all we're asking for is where is the numerator 0? That's one of the nice things about rational equations. If you can't make the denominator do something weird, you can just pretty much ignore it and say, well, that's what we're really wanting. Where is the numerator 0 as long as the denominator is not undefined? And then we'll say, oh, that's just a difference of squares once we factor a negative out of it. And so we can say x is plus or minus 2, part of my critical numbers. And so I'm going to say, well, here's negative 2, and here's positive 2. I need test points. Negative 3, 0, positive 3, just finding numbers on that interval. And then we're going to find out what f prime is when we plug that value in. Negative 3 squared plus 4 over negative 3 squared plus 4 squared. All we're really looking for is what's the sign of this number, which means we could ignore the bottom because we're going to square it. So all we're going to get out of the bottom is something positive. So let's see, we've got negative 9 plus 4, so this is a negative number. And then if we plug 0 in, we get a positive number. And if we plug 3 in, we're going to get the same number we got here because we squared negative 3, so it'll be the same number. So now we know that on the interval, negative infinity to negative 2, the function is decreasing. From negative 2 to positive 2, the function is increasing. And from 2 to infinity, yeah, whatever. 2 to infinity, I don't want to hit my head on that stupid TV, that's why I'm being nervous over here. It's negative, so it's decreasing. Ta-da, have we answered the question?
Yes.
Okay. Wesley, I just did a problem, I don't know. Is increase, oh, and then verify your answer using a graphing calculator or some other graphing utility. How many of you have a graphing calculator on your phone? So about half of you do? I mean, that's perfect for doing homework. Is it a good one? Yeah, maybe we should take a survey. What's the good one? 37. Ah. Now, what's the problem with number 37? Is it what?
Trig.
Did you do it?
Trig.
The trig?
Not like
Because
the domains are restricted.
What did you say number 4? Did you do it?
Personal preference.
the domains are restricted. It's all
Yeah, but when you combine it,
rule.
it's, like, you have to say where cosine is and where this one is and where they intersect. I just don't like it. It seems kind of tedious. Sorry.
Because it's periodic, and so you have to say like plus or minus 2 pi. Oh,
They have to count my pies.
I don't even know if I remember correctly, but it really doesn't matter which order they're in anyway. So, product rule? So f is sine of x, which means that the derivative of sine of x is? G is cosine x, and the derivative of cosine is?
Negative sign.
Sine of this stuff. So according to the product rule, the derivative is cosine x times cosine x plus sine x times negative sine x. Whoops. Cosine squared x minus sine squared x. Boy, that feels kind of like almost like an identity of some kind, doesn't it? So we want where that's 0. So we'll say where is that 0? Well, it looks to me like that's a difference of squares. That's what I'd do with it. I'd factor it and say cosine x plus sine x. Whoops. And cosine x minus sine x. And then I can use the zero product principle and say one of those factors has to be 0 or they're both 0. So cosine x plus sine x equals 0, or cosine x minus sine x equals 0, which means where does cosine x equal negative sine x? And where does cosine x equal sine of x? Holy smokes. So with those, it's going to be all the square root 2's over 2, because we've got some that are saying where does cosine x equal negative sine x, and we've got where does cosine x equal sine x. So that's all the square root 2's over 2. So let's see, that's going to be pi over 2 Can we make this really short? Whoops, pi over 4. Plus or minus n pi over 4? Does that work? Where n is an integer. Should work. Right? We're on a roll. 67. So what's the problem with 67?
Hard.
It's hard. I was looking through the Larson calculus book. It has so many more problems that are easier, that help you learn the process. It's almost like I want to assign you the problem set from that book. Because this book, the problems get too hard too fast, I think. They don't give you enough time to really hit the little concepts before they're throwing the hard stuff at you. What?
You should do it.
Sounds like a great idea. Extra credit.
Oh, quotient rule, but this is not going to be a horrible quotient rule. Oh, let's do this. So the top piece is x plus 1. The derivative of the top piece is 1. The bottom piece is x minus 1, and the derivative of the bottom piece is also 1, so this should work out very nicely. The derivative is the bottom piece times the derivative of the top piece minus the top piece times the derivative of the bottom piece over the bottom piece squared. This is hard? Huh. X minus x is 0. Negative 1 minus 1 is negative 2. And where can we make that 0? Nowhere. There's nowhere we can turn negative 2 into 0. However, there's still some critical numbers, because critical numbers are also where it's undefined. Are critical numbers where the derivative is undefined or the function itself?
The function itself is because it does the one right before it. So like you're doing f and then f prime, right before f prime is f. You're doing double prime, it's f prime. So inflection points over this one's under like 0, where it changes concavity. And critical is where the f is undefined. It makes sense in my head, kind of.
You didn't explain that very well. Not that it matters, right? Because we can look here and we can see that function has a vertical asymptote at x equals 1. The places where this is undefined are x equals 1. So our critical number is x equals 1. Which means that we just need to see negative infinity to 1. Whoops, sorry, that's not the way this book teaches it. Let me get rid of the interval and do a line. So we need a test point at x equals 0 and x equals 2. So let's see. My derivative is negative when x equals 0.